project, I decided to do elevators. But before I go ahead and talk about how forces are used in the movement of elevators, what are forces? Well, forces are described as a push or pull. They're vectors, which means they have direction, and the unit of measuring forces is newtons, and forces measure the motion of an object. And just think about tug of war, for example. If there's two kids, one on each side, and they're pulling with the same amount of force, nothing's gonna happen. They're gonna be standing in the same spot. Nothing's gonna happen to the rope because the forces are equal and they're balanced. But if one side had more kids, then the side with the more kids has a greater force, which means the forces are unbalanced and all the kids are going to move towards the right side because that's where the greater force is. So now let's talk about elevators. So how do they work? They kind of work like a pulley system. There's always a rope attached to the top of an elevator, and there's a counterweight to the opposite side of the rope, and that kind of helps balance the weight. So what are some of the forces that are present on an elevator? Well, one of them is of course gravity, which helps the elevator move down, and something that moves the elevator go up is tension, which is within the rope. So how does it move? And the answer is tension. Newton's second law states that an object in motion will stay in motion unless acted upon by an unbalanced force. And this is true in this case because if an elevator is going down, it's gonna want to keep going down unless there is a force to stop it, like an opposing force, which in this case is tension. So for elevators, we have three scenarios. Going up, which means the tension force is greater than gravity. Standing still, which means tension and gravity are equal. And going down, which means gravity is greater than the pull of tension. So with the help of Newton's second law, we're able to calculate tension. So let's try an example and see what we get. So let's say we have an elevator with the mass of 1000 kg, accelerating at 2 meters per second squared, and the forces are force of tension and gravity. So according to Newton's second law, F net equals mass times acceleration, and the force of gravity equals mass times gravity. And we also know F net equals the force of tension minus the force of gravity, which can also be written as mass and gravity. And if we rearrange that, we get an equation which is the force of tension equals mass times acceleration plus mass times gravity. So if we're going up, we're going to use the same equation and we're going to sub in our numbers. And for gravity, since it's going up, we're going to keep it positive 9.8. So the answer we get is 11,800 newtons for going up. So now let's try going down. we're going to use the same equation and the same numbers, except this time, since it's going down, gravity's negative, which means it's going to be negative 9.8. So we get a negative answer, and the negative just means that it's going down, but the force of tension is 7,800. So for going up, we got 11,800, and for going down, we got 7,800 newtons of tension. And standing still is obviously zero because they cancel out because they're equal. So now that we calculated tension for each scenario, let's compare. So for going up, in the last calculations, we found out that force of gravity is 9,800 and the force of tension is 11,800. So that's greater, which means it's going to go up. But if it's going down, the force of gravity is still the same, but then the force of tension decreases and it's 7,800, which means the force of gravity is greater, and so the elevator is going to move down. So Newton's third law states that for every action, there is an equal or opposite reaction. So consider a scale. So if you're in an elevator and you're standing on a scale, so there's one scenario where it's gonna go up and one where it's gonna go down. But either way, when you're standing on it, the person is pushing down on the scale and the scale is pushing up on the person. So the inertia of a person wants to make them go down due to gravity, and when the elevator is traveling up, the elevator and scale are moving up, but the person is pushing down on the scale, which means their weight appears greater, and that's because of the greater force exerted by the person on the scale. When the elevator is moving down, the scale and elevator are moving down as well, and the person's inertia makes them want to go down too, and since it's all in the same direction and there's no opposing force, less force is needed to go down, and that's why your weight may appear less too, because it's all in the same direction, whereas in the other one, you're pushing down and the scale is pushing up right here. So now that we talked about how elevators move, what are some advantages of elevators? So elevators are really efficient for building space because, for example, escalators, they take up way more space because they're kind of built like diagonally, and elevators are kind of just built on the side. They're way more convenient for people that have to carry like a lot of heavy things. So now let's talk about disadvantages. So it's not really that safe because it kind of depends on like the pressure, and it's also way more expensive, and you'll constantly have to get it checked to see if it's working well. So what are the effects on the environment? Well, elevators actually save a lot of energy because when you're not using it, they kind of stay in one place and kind of shut off, whereas escalators, they keep moving. And they also have energy efficient lighting, which again, when they're not in use, it's turned off.